This is Daryl with Cisco Hands-On Training. It's Halloween, the 31st of October 2009. Today we're going to do a hands-on exercise with IPv6 static routing. Again, the website is ciscohandsontraining.com, or on iTunes you can search on Cisco Podcast. One thing I forgot from the IPv6 theory class 2 sessions ago was to talk about IPv6 DNS entries. We haven't covered DNS, but in DNS there are DNS is the domain name service. That's what's used on the internet to map host names to IP addresses. And in DNS, if you have your DNS administrators will put in A records, which map host names to an IPv4 address. For IPv6, we now have a quad A record, and that maps a host name to an IPv6 address. And you can have the same host name with an IPv4 address and an IPv6 address. Another relevant DNS record is a CNAME. A CNAME maps one DNS entry to another DNS entry. So you can set up one host name with a bunch of IP addresses with an A record, and then you can have 20 CNAMEs pointing to that host name, for example. Now, under what circumstances will your computer choose to use IPv6 transport? Your computer will choose to use IPv6 transport to reach the destination. It will prefer it if two conditions are met. The first condition is that you have an internet routable IPv6 address. So an IPv6 address inside 2000:/3. So an IPv6 address starting with the digit 2 or an IPv6 starting with the digit 3. Because the first three digits have to be 0, 0, 1. And then the second condition is if the destination host name has a quad A record. So this is important. There are, if you're running a web server and you have an A record today, as basically all web servers do, then you have a choice. You can create a quad A record or not. If you create a quad A record for your website pointing to an IPv6 address that your website is on, then instantly every host on the internet that has an IPv6 routable address will attempt to get to your website via IPv6 first, and only if it times out will it attempt to reach it via IPv4. Now, the failback to IPv4 sounds good, but the reality is when you're web surfing, if you have an IPv6 address and the website is a quad A record and you try to reach that website via the quad A record, your web browsing is going to be horrible. You'll be sitting there for minutes if you can't get there over IPv6 and your computer is trying to. So the decision to deploy quad A records on websites, especially revenue-generating websites, is not one to be taken trivially, and there's some risk involved. The key message is if you're running a network with a website and you want to put in a quad A record, make sure you have good IPv6 connectivity to the internet before you do that. In addition, even today, just because your connectivity to the internet is good doesn't mean that the IPv6 routes that your autonomous system is advertising in the IPv6 internet, that route is making it through the whole IPv6 internet today. Recently, Aaron and the other internet registries started allocating IPv6 address space directly to enterprises. Up till a few years ago, they would only allocate IPv6 address space to ISPs, and the ISPs would subdelegate to enterprises. But enterprises with high-value websites like to have their own address space, and then they multi-home to multiple ISPs. And so now enterprises are starting to get their own address space, and that address space is sometimes /48s. Well, some ISPs are still only accepting routes for /32s, which is the standard allocation for an ISP. So if you're an enterprise, you get your own /48, you advertise it to multiple ISPs, You create your website, and your website, you generate a quad A record, and then suddenly some people behind some other ISPs that you're not connected to out on the internet can't reach your website anymore. Well, guess what? Those ISPs out there on the internet are probably not accepting /48s, even though it's now okay and within policy for enterprises to directly get /48s if they meet the criteria. One of the key criteria of which is that those enterprises multi-home. Okay, so that's the discussion of A records and quad A records, and when a computer will prefer IPv6 transport over IPv4 transport. Let's get into today's session, which is on IPv6 static routing. Here's our map for today. We have 3 routers. I'm using the IPv6 prefix 2001:0db8. Actually, I've got a typo here. That's supposed to be colon. Actually, no, that's not a typo. 2001:0db8:0. It's supposed to be actually 2 colons there, and that's my that's my prefix, and then my subnets are here. So actually, the first 48 bits are specified here for my whole map. And that's so I don't clutter my map with having the 2001s everywhere. So this subnet here, for example, is 2001:0db8:0:2:1/64. That'd be the IPv6 address. So let's go ahead and, so I have in my environment here, I have 1, 2, 3, 4, 5, 6 subnets. 2 of them are /64s. I have one that's a /126 just to prove that I can. These are point-to-point subnets, so /126 is fine, but the recommendation is to use a /64 for all subnets other than loopbacks, and then I've got my 3 subnets which are /128s for loopbacks. Let's go ahead and let's start by doing our configuration of the IP addresses. So conft int loopback 0 IP v6 IPv6 unicast -routing. I enable that in global config mode, and then int lo0 IPv6 address 2001:0db8. 0db8 is known as the documentation prefix. This is a prefix reserved for documentation. Nobody's supposed to use it in production. The internet will not allow it to, it should not be advertised on the internet. So IPv6 address 2001:0db8:0:1:1. So we expand this to all zeros. 1 at the end /128. And then int serial 0 IPv6 address 2001:0db8:0:2:1/64, and clock rate 64,000. Oh, that only applies to DC interfaces. Obviously, this must be the DTE. And then int serial no shut, int serial 1 IPv6 address 2001:0db8:0:1:5/126. Clock rate 64,000, no shut. And I would do a write mem if this was production right now. And now let's go to the middle router. Conf t IPv6 unicast -routing, and then int lo0 IPv6 address 2001:0db8:0:1 1:2/128. No shut. Int serial 1. IPv6 address 2001:0:8:0:2:2/64. Clock rate 64,000. No shut. Int serial 0. IPv6 address 2001:0:3:1/64. No shut. And then on my map here, I finished configuring this router and this router. So on this router, I should be able to ping this router's serial 0 address at or 2001:0:2:1/64. Let's see if that works. Ping 2001:0:DB8:0:2:1, and I can ping it. Great. If I do a show CDP neighbors, I can see I got one neighbor up. That's, again, I should do a write mem now. I'm not, just because I'm in my lab. And then top. Oh, I'm sorry. I already configured the top. I want to configure the bottom router. T IPv6 unicast --routing int LO0 IPv6 address 2001:0 DB8. Actually, I could do DB8:0:1:3/128. No shut. Int serial 0 IPv6 address 2001:DB8. Again, the shortening rules, since I only have 3 hexadecimal characters in here, the digit to the left would be expanded to add the 0. And then :0:1:6/126. Again, that's the subnet I'm doing the /126 on. No shut. Int serial 1. IPv6 address 2001:0:DB8:0:3:2/64. Clock rate 64,000. No shut. Back to my map. I already pinged across this link. Let's try pinging across this link and across this link. So the first one will be this pinging 2001:0:DB8:0:1:5. Ping 2001:0:DB8:0:1:5. And that pings. And then the other one, ping 2001:0:DB8:0:3:1, and that pings. Okay, great. I can ping across all these links. So what do you think is going to happen if I try to ping this loopback address up here? Think about that for a second. I'm on the bottom router, and I want to ping this loopback address up here. Let's try it out. Ping 2001:0:DB8:0:1:1. And it's failing. Why is it failing? Well, let's look at our routing table. Show IPv6 route. And here in my IPv6 route table, you can see I am directly connected to the subnet. Let's see. Here's my direct connection to my loopback. And yeah, actually this is interesting. I have 3/128 routes here. And those 3/128 routes are for the IPv6 addresses on my router. The one ending with 1:6, one ending with 3:2, and one ending with 1:3. So even though this is a /126 and this is a /64 and this is a 128, I get 3 /128 routes. This is my loopback. This is my IPv6 address on my link to the middle router, and this is my IPv6 address on the link to the top router. And then, in addition to that, I have 2 connected routes. The 2 connected routes are actually for the subnet. So I have a /64 and a /126 that's connected. And actually this /128 is both a loopback and a connected. So what is L means local. So when it has an L here, it means local. And when it has a C, it means connected. So those /128s are all locals. And then the /126 is a connected. That's my link to the top router. The /64 is connected. That's my link to the middle router. And then this /128, which is my loopback, it's a local IP address, IPv6 address, and it's the directly connected subnet, because the connected subnet is also 1/128. So I get the L and the C flags here. Now what I don't have is a route to 1:1/1/128, the loopback and the top router. And the question is not, why do I not have the route? The question is, why would I have the route? There's no reason for this bottom router to know anything about what subnets are attached to the top router. The only thing the bottom router knows about is what is directly connected to itself and configured on itself. And the reason is because routing protocols solve this problem. A routing protocol is a protocol that allows 2 or more routers to communicate and share their routing information. And we are not running a routing protocol here today. We have not configured a routing protocol, so there's no protocol that allows the top router to communicate its routes to the bottom router. So for the rest of the exercise today, we're actually not going to configure that routing protocol. We're going to configure static routes and show that you can do it with static routes, and show that it's a very painful and error-prone process. So here on the bottom router, conft IPv6 route 2001:0db8 : I want to route for this loopback, I want to route for this /64, and I want to route for this loopback. This loopback will have this as the next hop, this loopback will have this as the next hop, and this /64 can have both of these as next hops. So IPv6 route 2001:0db8 : 0:1:1/128, and then I type in my next hop, 2001:0db8 : 0:1:5/126. And what did I do wrong? Conft IPv6 route 2001:0db8 : 0:1:1 oh, I'm sorry, 128:1/128. I know what I did wrong. And then the IPv6 address of the next hop does not have a net mask. You can see up here, when I did my first one, I tried to put a net mask on my next hop, and the next hop does not need a net mask. The next hop is just the IPv6 address of the packet you forward to. So 2001:0db8 : 0:1:5. And then for the other loopback, IPv6 route 2001:0db8 : 0:1:2/128 : 2001:0db8. It's my next hop. So this is my target of my target of the static route, and then here is the next hop: 0:3:1. The next hop is this IPv6 address to get for the static route, which is destined for this one. And then I need IPv6 route for the /64, the remote /64. IPv6 route 2001:0.0db8:0:2:1/64 2001 next top is 2001:0.1:5. And I actually have I have two next hops for the /64. I can get by with one, or I can get by with this one, but for maximum redundancy, I'm going to put them both in. :3::1. So now I do want to show IPv6 routes. And you can see I have some static routes. Here's the static route for the /64 with two next hops. Here's the static route for the top router with my link to the top router as the next hop. Here's the static route for the bottom router with my link to the bottom router as the next hop. And now let's try this ping 2001:0db8:0:1:1. And it works. So what's happening here is I'm sending the ping from the bottom router to this loopback. I have a static route which says this is the next hop. And then this router, the question is, how does this router know to get back to me? And the answer is, when I generate the ping, the source address of the ping is this is my IPv6 address that is closest to the route out. So when I'm sending a ping to this target, my router from my static route, I know that I should send it to this address as the next hop. And so this is my IPv6 address that is closest, so I use this as a source. Now, the top router knows how to get to this IPv6 address because this IPv6 address is directly connected to the top router. Now, if I were to send a ping with my loopback as the source, then the top router would have no idea how to get back to me because the top router does not have any static routes or any dynamic routes installed to know how to get the loopback of the bottom router. Let's see if we can try that. Ping protocol IPv6. Target IPv6 address is 2001:0db8:0:1:1. My repeat count, I'll do it 3. Datagram size 100. Timeout in seconds 1. Extended commands, yes. UDP protocol, nah. Precedence, no. DSCP, no. Include extension headers, no. It didn't let me specify the source IPv6 address, which is disturbing. That's a feature that you need, but again, this is a pretty old router, so it does not have a full IPv6 feature set yet. In IPv4, you can specify the source IP address of your pings if you use the extended ping commands like that. So, okay, so let's go to the top router. And just to test that it doesn't know how to get to the loopback on the bottom router, ping 2001:0db8:0:1:3, and you can see it can't even generate the ping. It has no idea where to send the ping, and it can't even pick. And you can see that it's trying to, in order to generate the ping, it needs to pick a source interface to ping from, and it can't because it doesn't even have the route. Show IPv6 route. And then you can see I've got my 3 directly connected routes and my 3 local routes. This one for the loopback is directly connected and loopback, the same at /128. I have these 2 other routes. FF00::8 is multicast, and FE80::10 is link local. And so if actually strike that. We'll talk about that some other time. In any event, of these routes up here, don't strike that about that. We'll talk about it now. Remember, all IPv6 addresses starting with FF are IPv6 multicast. And if you have an IPv6 multicast, then there's a local route here, meaning that the CPU needs to think about it. It'll get processed by the CPU, and the CPU will make a determination based on what's in there. And then FE80, well, you can see null 0, so it's actually throwing them away. So FE80, if the router has a packet that's destined for FE80, it's just going to throw it away at null 0 because that's link local, and it should never forward traffic along link local. And we have IPv6 unicast routing enabled. We do not have IPv6 multicast routing enabled, so multicast traffic, the same thing happens. Okay, top router. I needed to enable some static routes. Conf T, IPv6 route 2001:0db8:0:1:3/128. That's the IPv6 address of the bottom loopback. And my next hop, so that's the IPv6 address of the and the /128 of the bottom loopback. And I need this IPv6 address as the next hop. And of course, the next hop is just the IPv6 address, not a mask, because the mask indicates the whole subnet. So the next hop is 2001:0db8:0:1:6. And then for the other loopback, IPv6 route 2001:0db8:0:1:2/128. Next hop is 2001:0db8:0:2:2. And then for the /64 between the middle and the bottom router, IPv6 route 2001:0db8:0:3:/64. :/64. And then the next hops, I have two possible next hops, 2001:0db8:0:2:2. That's my first next hop. And then my second next hop would be :1:6. So now if I do a ping 2001:0db8:0:1:3, I can successfully ping from the top router to the bottom router's loopback address. And then I need to do the same thing on the middle router, where I create, in order to complete the routing of this environment, I need to create those 3 static routes, actually 4 static route commands, because one of them I have 2 next hops on the middle router. So I have 3 routers, I have 6 subnets, and in order to get full routing working, I need to do 4 static route commands on each of the router for a total of 12 static route commands. You can see how difficult it was to keep up with all of the :0db8:0:0, blah blah blah. Static routing is very error prone. And static routing seems simple intellectually, because you're just saying, hey, if I need to go to this target, go to that next hop. But when you actually start using it in production, even in a small environment, manually configuring all those static routes results in errors. And then static routing does not reroute around outages. Like, for example, if this link went down here, the top router would not be able to get to the loopback address on the bottom router, even though it has a valid path via these 2 routes. So static routing does not reroute around failures. I've seen a lot of network engineers have a problem. They need to figure out how to get a packet from, they got an environment with like 20 routers or something. They need to get a packet from router D to router E, and it's just not getting there right now. Or they just want to deploy a static default route to get the packets 1 hop closer to the destination, then everything else works. Each time they do that, they're installing a time bomb. Once you have all these static routes, you can't reroute around failures. And someday in the future, you're going to do a network change, and the static route is going to still be there, or that static default route is going to get redistributed in your routing protocol, and you're going to have an outage in the future. So static routing is an essential skill to have. There are places to use it, like at the edge of your network, like connections to labs and stuff like that. But dynamic routing protocols dynamically route around failures and help recover from outages. So That concludes today's class on IPv6 static routing. Next class we'll do IPv6 RIP next generation, which will be the first IPv6 routing protocol we cover. Thank you.